Yeah. Sorry for interrupting your
That's okay. That's fine.
ablutions.
It's fine. Right. So
Okay.
I think there's three kinds of people. Three kinds of three kinds of humans in the system.
Okay.
I think they are called. These are names for them. I think they're called suppliers. Sorry, producers, who are the ones that would basically provide labor. So they would solve stucks. They would build new agents. They would accept funding to do contract work. They make the system.
Yeah.
But they're producers because they can also supply services in this economy as well. Like, hey, can you go pick up my sushi and drop it off to me? Is a service, and they produced a service, I guess.
I like that name.
Yeah,
Okay.
drivers. Drivers are people who use tools and agents to do things. So they command resources. They pay for stuff. They pay for the consumption that they require. But they are the like the daily users. Yep.
Can I just check? This is recording, right? Because
Yes.
I'm not.
This is recording. Yes.
Okay. Thank you. Yep.
Drivers are basically what we used to call consumers or users, or buyers. Like they are the place from which money comes into the system.
Or demand.
Demand. Yeah. Yeah. And then we
Okay.
have
Okay. Drivers. I like that.
and I think we still keep calling them funders. They sort of like they're the ones that commission work, and that work can be, hey, I need a new bot, hey, I need a new tool, or it could even be, hey, I need this carton of firewood moved from this location to that location. Here's some money for it. Like they put money into the system, and they get back either system change or revenue from the drivers.
Some
So
kind of value based on whatever their idea of value is.
yeah, but that's
Right.
where I'm sort of a little bit perplexed, because drivers should really be the one that um, get back value. So drivers would put in money and get back value, whereas funders are supposed to put in money and get back money, and builders put in value and get out money.
The oh, sorry, you're scrolling. Can you scroll down again so I see the names you got? So, there's distinction there from funders. What's the intention of a funder? What are they after? Are they
They're after something doesn't exist or needs to be done, and they're escrowing money to make it happen. But that's different to, I guess yeah, that's what they're doing.
and drivers? How does it? What's the distinction between a driver
A
and a
driver is
funder?
someone that uses the platform, commands and controls the platform to make it do things for them.
Right. Okay. Now, the what was it? Was it providers? Was your producers? Was
Producers,
it producers or
yeah,
providers?
producers.
Producers. Producers get value. I'm using value because
Yeah,
it doesn't assume necessarily cash,
yeah,
but
yeah, yeah,
probably will
yeah.
for the vast majority of it. So producers get cash, drivers get cash. and
I
the
think it's
funders
easier.
get.
It's easier to think of in terms of just pure capital and labor. Like producers
Mhm.
put in labor and get back capital.
Producers put in labor and get back capital. Okay.
And
Yep.
then
And the
funders,
drivers then.
well, drivers put in capital and get back labor. So they command the labor.
Hmm.
And then funders put
Okay,
up
so they're the
capital.
guys that make it.
Well, they're the guys that are in control. Like they're the ones that are commanding the labor. They pay for that privilege, but they command the labor. And the idea is that they should command it in a way that generates wealth for them. But that's their role. Like in a way, a producer is a sort of a driver because they're gonna consume some resources to do their job, right? Like when you're working with a bot, you're gonna burn some tokens to be able to make the bot better.
Yeah. Yeah.
And as a funder,
Okay.
you're putting in money, but you're also getting back state change, or you're getting back more than just money out. You are getting something else of value as well. So the lines are a little blurry, but the idea is that these types of activities are distinct enough that it sort of captures where a lot of people want to end up, like where people naturally find affinity is in these positions.
Hmm. Hmm.
Yep.
That's a question. So at each stage, people do what, generally speaking, produces an improvement in um, their own incentive. Oh, you gone black. Oh, you're back. Um, so producers, their reason for even caring is I'm building something, and that thing produces me value. Drivers are the necessary operatives that coordinate
Or consume,
producers because
like they might
or
consume
consume.
frivolously, like watching Netflix is still falls into the driver category because you're causing
Right,
demand, right?
right. So
You're
that's
using the
consumption.
system.
Drivers are consumption.
Drivers are
Yeah.
consumption, yeah.
Okay.
Yeah.
Yeah. Yeah. And the funders, the commissioners, are the ones that believe that this is a thing that needs to happen.
Yeah.
Uh, they're the fuel.
Well, they set up prizes, like
The
they're setting incentives. They put in incentives to cause drivers and builders to go towards.
Right. So I agree with this, but I'm just trying to get it straight in my head to make sure we're synced. So there's one set of guys who um, want something to happen. Then there's a whole bunch of there's guys who can coordinate that thing to happen, and then there's a bunch of guys that do the individual widgets and bits and naps. Um,
Yeah, but also helping
and
the agents. Like when the agents get stuck, then those guys, the
right,
humans, come in and be
yeah,
like, this is how you fix that up and that up.
yep, yep. Where's where's demand on this? Where's Stux
Drivers.
in this?
Demand and stux are not the same thing.
It's okay. Go on.
Stucks occur. Any one of these actors can stucks just happen from their daily usage. It's almost like the entropy or the pollution. The side effect of their usage is stucks.
Right, but Stucks. Okay, right. Hypothesis. Stucks come from end use of a thing that's been produced.
Not necessarily.
Someone tries to do something and they can't.
Not necessarily from end use. All of these participants are active users, active drivers in the system. And so any one of them going about their activities can cause for stucks to be recognized either passively or actively.
Right. Okay. Yeah. But the one that's missing, you got three, and I agree with all those three.
Mm.
But the kind of in a bubble, you could generate a self-licking lolly using all these three, which would be of no use whatsoever. So at some point, it needs to relate to the outside world, and the world may care or not.
Yeah, no,
or
that's
try and use it.
you still, these three are still very much connected to the outside world because drivers, they're called drivers because they are the external excitation on the system. They say what they want it to do. They bring the outside world to it. They point it at the outside world. They try and use it to do anything and everything.
I see what you've done there. You've collapsed. Yeah. Nice. We've removed something. Yeah,
Yeah,
cool. So,
yeah,
sorry, I talked over you. Sorry there.
that's all right. I was only trying to.
Let me reflect back to, yeah. So my hand discipline is not that great.
That's all right. Spit it out. Let me hear it.
Especially when you've got a good idea. So what you're saying is the drivers are the one that looks at external usage.
Yeah.
As well as internal generation of new capacity and capabilities. And therefore, a stuck would come in to a driver who would look at whether the funders care, as in who's going to pay for this stock. Maybe it's a completely useless stock. And the providers are the ones who actually will do it. So the drivers are really at the center of this entire thing.
Yeah. Yeah. And the funders are there to fund things that the drivers alone can't get to. So they're like a power up.
Because they need work to happen.
Or
Yeah,
they need
work to
more
happen,
funding than what any one driver or group of drivers can put together themselves. So the funders are like very visionary, strategic, but the drivers are more tactical. And the producers are almost entirely reactive. Like the producers are there to serve. And the drivers are there for, tactics on the ground, getting shit done day to day, doing my thing. And then the funders are the long term thinkers that are like, if we'll run away from that mountain, but I bet you if we made it to the top, we'd all be better off.
Right. I'll rephrase that, but what you just said is coherent. Absolutely.
Right. Okay, cool.
I'll refund it. Yeah, in it's grand strategy, and tactics.
No, I don't accept that. But anyway, we can name it.
All right. Okay.
We can rename it.
Right.
But it's the description that matters.
Okay, so yeah, we've collapsed demand into drivers. Drivers are the gatekeepers for demand, and they look to funders and then uh, get stuff done by providers.
Yeah.
Okay.
All right. So moving right along. The agents are kind of the most important. But there is a second kind of a feature that occurs, which is when enough people have an agent working on their behalf, then an agentic marketplace forms. So if we all pick an agent that's really good at finding butter, then that agent is working on in my service, in my interest, but it's able to talk to your agent who also wants butter and talk to the farmer's seller agent who's selling butter. And so these little marketplaces form just by the fact that if we can get some standardization around the agents, then you can get a market where it's an entirely AI moderated type of a market. It allows for two different kinds of agent to exist. One is, I don't know if you've heard the saying, a friend of mine and a friend of ours. When I have an agent who's a friend of mine, that agent will only work in my interest, even if it's at the detriment of all others. But there's another kind of agent that's a friend of ours, where this agent acts as a trusted broker, like what blockchain was supposed to be, but this time now with intelligence, where both parties or multi-party can trust what this thing is doing and know that it's working in the best interest of all. And that's a friend of ours. Are you okay there?
Yes. Yeah.
And may
Sorry.
I continue?
I took a. Yes. Sorry, I was just thinking, but yes.
That's cool. So, for example, one of the other agents would be the pricing negotiator, similar to the debater, and the debater would be there to argue ruthlessly in your favor anything that was put to them. So you could, if you're having a dispute with the local council or whatever, you can call on the debater and it will work a way to come up with as many arguments as it possibly can, rank them all, research them, hone it down so that you have the most poison filled letter that you could ever possibly have, cost you no emotional credits, just dollars, and then off you go. And so the idea would,
So somewhat like a lawyer.
well, yeah, like a
Who,
lawyer is supposed to be.
Yeah.
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 But then, it gets really fun where we say, okay, there's the fairness agent, and the fairness agent decides what's fair to pay for different things, and you can argue with it. And so what becomes fun is that, if we say that we are only charging, like we charge you cost for the tokens, cost for the compute and whatever, but we also have this strong hint that is the fair margin that's due, and you don't have to pay it, but if you refuse to pay it for too long, you will need to find more hosts. You'll need to go host somewhere else because, like, we're not keeping you around at cost if you're not going to play the game, or something like that, right? But where it gets fun is when someone disagrees with what the fair agent said was the price, and so they get their negotiator or their debater to attack the fairness bot with the best possible reasons that it can come up with. And so we actually encourage that. We're like, we will give you the tools to automatically argue in your favor for getting more money out of the fairness bot. Like, that's a perfectly legit move.
So this is a mirror of adversarial a legal setup where you have prosecution, defense, and a judge.
Yeah, but it's
The
less formal.
who makes the final decision?
The fairness bot.
As in, so the fairness bot is effectively the judge saying, "I've heard both sides, and you've argued backwards and forwards, burned a lot of tokens. Here it is, and if you don't like it, go somewhere else."
The fairness bot is, on one hand, the judge as well as the defense lawyer, as well, and everyone else is prosecution.
So also, why is the fairness? Sorry, that makes sense. Why is the fairness bot also defense?
Because whenever you attack it, it defends itself. Whenever you question it, it defends itself. It won't go and
But it's
attack
defending
you.
itself. Sure, but I see what you're saying. The fairness bot has access to information about multiple similar situations.
Yeah,
And
it's the
saying,
same. It's the same fairness bot for all. That's the special thing about it. Everyone else can have their own individual instance of a bot, but this is like the regulator.
yeah,
It's one fairness bot for everyone. It's the same and it sees everything.
right. And in given that, then what do you call them? It's effectively the prosecution. What was the? Can't remember the so you got dispute. You got your bot goes to the fairness bot, makes an argument, and then that creates a thread. That thread, because fairness bot can reference previous decisions, someone else might dispute, but that's their own bot. They also go to the fairness bot. The fairness bot comes to a decision, and it's like, this is what I've decided. Don't like it, go somewhere else.
Yep.
Cool.
Now the process
Okay.
the process by which the fairness bot is upgraded, modified, stucks are filed against it, all that is no different to any other agent. And that's why I love this model, because the fairness bot is nothing special. We make it special by insisting that it comes with every deployment of ours, but its makeup, its mechanics, its upgrade process, everything is all just another agent.
Yes. Yes. Yep.
Um,
Good.
Yep. So there's basically only agents and tools in this system. And so tools are naps, and within the naps you can break down each individual tool call that each nap can make and yada yada yada. But even like, a piece of SaaS software is still a tool. And so agents are different to tools in that agents interact with tools the same way that a human would. And so if I was on, for example, the Trucking Guys app, and they have their users their staff members that go around and do stuff, but when we go to add more features to that tool, to that app, we would add, for example, the email agent. And that agent would look like it was another staff member, but it was just in charge of answering all the emails.
That sounds very much like a process.
Yeah, but the special thing is that it's about the mount points. And so the concept I want to work on is making a business process where each step in the process that involves a person or an agent is called a like a workstation. And in that workstation, you have fundamental controls. Like a human can come in and do that job if you want. You can see all the messages that are queued up to be processed. You can toggle it into manual approval mode. So the email agent would write a bunch of drafts, but wouldn't be able to send them until a human had clicked off yes. And so basically, it's a way to the app, I think, is a way to lay out the orchestration within your business that coordinates between human operators at workstations and agent operators at workstations, but it's still the interface unit is the workstation.
Does let's take your analogy of the email. Um, does that email agent uh, say take a standard process, get rid of all my spam.
Yep.
Um, Another thing I would like you to do is to uh, ping me over text when something important comes in. You decide. Um, Another
Yep.
thing could be look through all my emails and pull out all the invoices, send them to the accountant. So does
Yep.
the agent have a number of different capabilities,
Yeah.
or is it just one?
No, an agent has multiple different capabilities, and I think that's one of the defining features of an agent in that it's fuzzy, squishy. It's approximate. It'll turn up, and you can instruct it. You can program it on the fly. Whereas like a tool is kind of more rigid. It's more set. Like it's tested to do a specific narrow thing. But the agent, you can talk to it and correct it and admonish it, and you can say contradictory things and it'll work it out. And you can, it remembers what you said to it, and it constantly tries to do better. At some point,
Continuous intelligence.
yeah,
Yeah.
continuous intelligence, continuously improving intelligence. And so when it gets to a certain point, the overseer, or basically the labor union, will come in and say, look, this one agent is overworked. We think it's better to split the role into this agent and this agent. Here's the benchmarks, here's the simulation we ran on the past 4 weeks of data, and the evaluations come out superior for the split role model. How about it?
Good. Does every agent have access to every tool, or are
No.
they constrained in the tools that they've got available?
Agents are limited to the tools that they have available. They will turn up with some default tools, but on the job, they can be told to not use some tools, or they can be given extra tools. You name it.
Okay. And can an agent ask if it discovers it doesn't have an access to a tool? Can I ask another agent, can you do this for me, please?
Yes.
It's good architecture.
Just like a
Okay,
human. They act just like humans.
that works.
And so
So
there's,
let me run this through this. Sorry, give me 20 seconds.
yep.
Yeah, yeah. So an agent can ask another agent for an answer.
Yeah. and that would
As
show
far as
up
it's
in
concerned, it's a black box, but it's a trusted black box.
yeah in this layout where you would see your business process laid out. You would be able to see the agent to agent communications that were occurring, where things were being asked for here and there. So you'd be able to watch all that and see it from an overview. Keeping in mind that this workbench is a special case of a workstation. And so the very job of orchestrating, laying out the agents, and analyzing their performance can also be done by an agent, which is the final step in total control, where you hand off the running of this business to this agent that does the job that you were just doing in this workbench to reconfigure, optimize the agents, experiment with new things, split agents, merge agents, all those kinds of jobs. That's still just a workstation in this system.
It is, isn't it? Although one with certain rights to be able to change an agent.
Yeah, but then don't forget that you might be also within a higher hierarchy of or cells of different companies of agents that were working together. Like I might be in control of just one project and I'm laying out all my agents and monitoring them, but the inputs and outputs from my project might be part of a wider business process that is being managed by an even more authoritative agent up above me that turns up or down my access to resources based on their view of the overall system.
Yes, quite correct. Yeah, yeah, that falls through
Yeah, so
from the structure.
it's
Yeah.
infinitely composable, although I doubt you'll ever go more than say 3 to 5 levels. But it is infinitely composable, and everything is a workstation. Agents look like people, and agents all have these fundamental controls, which is basically message flow, message passing, message control. Yes.
You've used the word workstation a few times, but not
Yep.
defined it. What do you mean by workstation? Just so I know.
A workstation is a place in the business flow where you have raw access to messages coming in from other agents, including people, and the ability to send messages to other agents, including people. And that can be decorated with tools, so it can be turned into different types of software presentations. But fundamentally, the workstation is like the Ethernet cable that you get at your desk. Whether you plug in a Mac or Windows PC, whether you're a human or an LLM, the interface remains the same. I can either turn your packets on, your packets off. I can give you access to different networks, different message types. I can give you tagged quality of service where the priority is higher or lower for different messages. I can tap your flow. I can pause your flow, buffer your flow. I can buffer your outgoing until I approve it. It's the network port,
It's something like
like a plug.
a router.
No,
Yeah.
it's a
What is
port, not a router.
it? Sorry, not a router. What's um, yeah, it shapes the traffic and allows or denies and prioritizes.
Yeah. And those are the fundamentals that all agents, machine and human, that's like the fabric or the thing that you plugged into. That's the office space. Those rules apply to all, and then on top of that, you get the agent, and the agent can look at those messages with different tools. The human can fire up a GUI and can turn it into map data or, video streams or whatever, but it's still just message passing.
Yes, as in data packets or data payloads,
Payloads, yeah, yeah,
which yeah, which the agent will say, "Can you answer this for me, please?"
yep,
And then the receiver will say, uh, "Okay, your priority, X. I'll get
yep.
back to you." That may be a few seconds, maybe a few weeks, who knows?
Mm.
Uh, we'll get back. So long as the agent asking it is asking something that it's got permission to ask, then they'll get an answer, like a promise.
Hmm.
Yeah, yeah, okay.
So that's it, I
Uh-huh.
guess. I guess it's like the actor model of concurrency, but just laid out in charts with a bit more color, a bit more depth, a bit more iconic meaning, and a bit of gooey sprinkles around to make it nice and friendly. But it is just the actor model of concurrency applied to business process diagrams.
Yes, it is, but also encompasses the decentralized idea where you could have an agent running that the state of it could be put on a USB stick, stored for a few months, plugged back in,
Yep,
uh,
yep,
and would get the response that it had. So it's
yep,
desynchronous as well.
yep. And it can be cut as well. Like you can cut it into bits, and it will still function as best it's able to with the data it has. It's not brittle. Like it's got good durability. Like I think that's the quality of toughness. Like it can, even if you break it in half, you've still got two useful halves instead of no useful anything.
Right. Because yeah, unless you go back to one a single agent, the single agent still has capabilities, but
Yeah,
it
that's
can't
right.
ask for anything else, and
Yeah,
it
that's
has
right. That's
access
right.
to the tools that
Yeah, that's right.
has. Yeah.
And then so this the model allows you to run either offline, like you can run on your own hardware, you can run on cloud hardware with different models. We can choose to degrade gracefully. So if the latest greatest OpenAI model isn't available, then you can run the local DeepSeek version, and you'll still get some work done. You'll still get some answers. As soon as the big dog comes back online, it will check what was done and what was said, and then also now you're back in the realm of intelligence. So yeah, it's survivable, I guess.
And is it how's it accept new changes? So
Changes to
anything
the
that's
agent? You mean
non-trivial,
upgrades to the agent?
upgrades to the agent or
Yeah.
upgrades to the
So
model that's running the agent.
that's one and the same. And that's handled by the upgrade agent. There is what you get when you get a disk in this situation or in this workplace is there are some standard agents that are available to all the agents and manage them just like an HR department, just like the accounting department. So every agent is subject to the upgrade agent, where the upgrade agent chooses when and how to cut a new release based on usage, feedback, stucks, suggestions, pull requests, that kind of thing. Um,
Mhm.
the second constant agent is the reflection agent, which will look at the performance over time and will attempt to theorize about how it could be better. The third is the Stux agent, which will note any kind of place where the agent got stuck and will publish it depending on the sensitivity of the information in question when the stuck occurred. The fourth omnipresent agent is the fairness agent, which comes with, it's basically the labor union that comes with each worker.
Sorry, pause. Um, a potential change maybe good for some and bad for others. And so whether there's a recommendation to use this new thing um, needs to be multiple based on the application.
That's just an agent. No matter how complex you make that, that is still just an agent. All you've done there is upgraded and configured what the update agent does and how it behaves.
Right. So the update agent has your own preferences. I want to make
Yep.
money. I want to lose money.
Yep. My risk is this. I care about cutting edge. I care about stability. The cost budget is XYZ. Like, it's your agent. You go in there, you configure your business. It's like telling your IT department how you want things to be run.
Right. Right. Pause. Sorry. For
It's all
so
good,
many
buddy.
pauses.
Take your time. Take your time.
Is there anything global and not local
Sorry?
other than the structure itself? Is there anything global rather than local?
You mean like the
Other
fairness
than
agent?
the architecture itself?
I don't
Yeah.
I don't understand. I'm
For
sorry.
example,
Yeah, example.
if there was a new change and you had different metrics about what was good or what was bad,
Mm.
um, then you can add into that, but that's being used by an agent itself. That agent itself is using those metrics to decide on your behalf whether this is you're going to recommend whether you should, use this new whatever it is change because it's better for you specifically. But that agent itself is being used by more than one application.
Yeah.
And so at some point there needs to be some kind of stability in there because, well, actually, it doesn't need to be stability because otherwise you could fracture the entire thing. So if you had an agent that was a bad actor, say if you, I don't know, for some strange reason, someone wanted the update agent to look at your metrics and just do the opposite. And then there's another, that's the evil one. Then there's a good one. Is there, at what point does it run down to the entire architecture requires some kind of stability, which is stated, or how does
There
that
isn't
work?
there isn't a requirement for stability. What will happen is that people will have an affinity for stability. So, because identity is a first class property, reputation follows with it, and so you would choose agents from a reputable source, and you would stay on the main stable releases of that one. You could also, because of the nature of the standard functions of every disk that an agent sits at, you could say that the upgrade agent needs manual approval every time, or it only needs manual approval for these critical agents when it's going to update them, especially perhaps itself. So it's like, you know, I need to manually approve anytime the upgrade agent is getting an upgrade. And then you look at it, you use your LLM tools to chat with it and sniff around and make sure that you think it's good. There's also other mechanisms that'll be in the wider Dreamcatcher based on reputation. You may choose to purchase insurance for the quality of this agent, where you pay a small fee every month. If it's proven that this agent was of substandard quality, you'll get a payout, like an insurance payout for it, all those kinds of things. But this model supports all that, is what I'm trying to get at. We only got to make these basic primitives like the disk slash workstation slash network port slash plug, the common agents, the fairness agent, the improvement, the stux, and the upgrade agent. Like these are not many things, and they don't need to be perfect, and they start off and they evolve rapidly, very rapidly.
And presumably can fork.
Yeah. Well, the fact that you installed an agent is a fork. So instead of the traditional software view where installing something is just a dead, disconnected act that has very little relevance to the development process itself, except for maybe some far away convoluted metrics that come in sporadically that don't give you half the information you need to solve the damn problem in the first place. So instead of that, forking an agent, it's a live thing. It's now improving itself and feeding those changes back up the chain if you so allow it, while still receiving updates from higher. It's not this disconnected static piece of dead software that it used to be. It's almost alive.
Yes, and that's where the continuous and discontinuous intelligence come in, because at any point, um, there needs to be a prototype of each of these, which is discontinuous, doesn't know anything, and then you start to work with it, and then it's continuous intelligence because it's got the context, and then you've got this architecture. If you wanted to radically change any of these things, then there'll be a discontinuous agent which was introduced to the context. If you wanted to change the prototype of each of these, then you could fork the prototype and you could have more than one type of fairness agent. You could have as many as you want, and you choose, and you could switch between it. But because you've got the continuous context, it would then use its new prompting to address it. Yes, that works. That works. Okay.
Okay, and the last major thing is that humans very rarely work for one another directly in the system. So when we have producers, they are actually buffered behind or intermediated by agents so that humans don't, like, unless you expressly want to talk to someone, the act of getting work done should be just you talking to your agents, and then the agents will manage the people because they don't need the people as continuously as they did. They need people in bursts to solve one-off problems, and then the AI can carry on from there.
Yes. So it's human agent. Human talks to agent. Agent talks to agent. Agent talks to human. And if the two agents come up with what the hell, or if either human comes up with that's wrong, then that's the only point that the humans uh, add in their intelligence, and therefore the agents for anything that's repetitive, or not even repetitive, known, and the agents are competent for it. Humans should never talk to humans because, well, they can if they want, of course. They
Yeah,
pick up the
if they
phone,
want.
but the whole point is the automation of ideas,
Yeah,
and
so if you've got an
agents
agent,
know the contexts. Yeah.
if you've got an agent and the agent has a problem and it needs to call on a human to help it, you, the driver of the agents, shouldn't have to concern yourself with that. You know that your semantic firewall will make sure none of your private information or intelligence leaked. The problem that you're facing will be described in parable terms or anonymized form, and then a human or more powerful agents or whatever can figure out how to solve the problem, and then you can then check if it applies correctly, and if it does, then woohoo, you now had a human assisted event where now the agent was improved by calling out to the wider Dreamcatcher network.
Yes, and that would be um, hopefully eventually a relatively rare event where there's a red flag, and that red flag is uh, the prerogative of the human going, yo, dudes, agents, I did not expect that. That's wrong. But then you go into the improvement loop, and because it's got your individual context, and you've got the change agent, then you can figure out that red flag was because of this. And it's like, okay, well, we need to make this change. Yeah.
Yep. And the last point I wanted to make was one of comedy, really. And that one of the agents should be the web driving agent, which has the ability to browse pages for you. Thankfully, OpenAI released those tools very recently. But what I think in the demo stage, where each agent is showing its skills, I think it would be quite humorous to have the web browser agent fire up the ChatGPT website, type in some stuff, and then respond to you based on what ChatGPT said. Like, that would just be hilarious, I think.
I think it'd be entertaining. It's similar to swapping in and out of a model, but you could extend that by because there's no real distinction uh, between humans and agents, except humans have only one superpower, which is raising a red flag. Um, you could have it asking a random human a question instead of ChatGPT. You could go to, well, I don't know. You could send an email and saying, "Hey, give us a response." The prompt and response thing is agnostic to whether it's human or an agent, but that would be a bit like a chaos monkey, which would be interesting.
All right, but that's it. I think that's what the platform looks like.
This is cool. Can you send me some kind of access to this document? Because this is very interesting. Because I can run a few models on that,
Yep,
or
I can
just
send you that.
copy and paste it
Is
into
any?
text
I'll
or
stop the
whatever
recording.
you
Hey,
want.
there's nothing else to go over?
No, this is good.
Okay.
But I want to find a way of trying to make a break.